This question is from GATE 2013 Mechanical Engineering paper, question number 41. A simply supported beam of length L is subjected to a varying distributed load sine of 3 pi x by L Newton per meter, where the distance x is measured from the left support. The magnitude of vertical reaction force in Newton at the left support is. Let's see how this will be solved. This is the beam which is simply supported on both ends. So we can draw the free body diagram like this, along with the load, external load acting on it. To determine the load, we'll see x equal to 0 is at the left support because x distance is measured from left support. Now the load magnitude is sine of 3 pi x by L Newton per meter. This is the non-uniformly distributed load. It's a distributed load, but it is not uniform throughout. It is going to vary as per the sine function. So at x equal to 0, we see value of sine is 0. So it should start with 0 and then increase and follow the sine function. Now what will be the magnitude at the right support? So at right support we have x is equal to L, and when we substitute it here 3 pi L by L, we get the load value to be, this is 0, this load value is also 0 because sine 3 pi is 0. Sine of n pi is 0, and therefore we have this as sine function goes here and we get the magnitude 0 here. So this is the load acting on the beam. Now we need to find out this total load acting on the beam because we can see that the load is symmetric. If we take a point at the half length of the beam at x equal to L by 2, we see that both sides equal amount of load is acting. So the beam is symmetric as well as it has symmetric loading. Reactions will be equal to each other. So if we write vertical reaction at A, this point is A, this point is B, and vertical reaction at B, we know that VA will be equal to VB. Let that be V. So if this total load is capital W, by applying summation Fy equal to 0, we have capital W will be equal to V plus V, which is 2V. Now we can find V if we find the total load acting on it just by taking half of the total load. So let's find out the total load by integrating the load from 0 to L. So we'll have total load W will be equal to integration 0 to L sine of 3 pi x by L with respect to x. This will be equal to integration of sine is minus cos, and we have the coefficient of x 3 pi by L, which will be going in division. So we have the integration as minus cos of 3 pi x by L upon 3 pi by L, limits being 0 to L. Let's put the limits now, which will be equal to minus of L by 3 pi into cos of 3 pi minus cos 0. This will be equal to cos of 3 pi is minus 1 and cos of 0 is 1. So we have this as minus L by 3 pi into minus 1, which is nothing but minus 2. Minus 2 into minus 1 gives us 2. So it is 2L by 3 pi. So the total load when integrated has magnitude 2L by 3 pi. This shaded region has the magnitude of 2L by 3 pi. So V will be nothing but half of this value, which will be L by 3 pi. Let's go back and mark the correct option. We see our answer L by 3 pi is given in option B. So it is the correct one. To learn more about simply supported beams and their analysis, you can refer to the NPTEL video Lecture 13 Beams 4 from the course Engineering Mechanics. This course is by Professor K. Ramesh. He is from IIT Madras. I hope this solution will help you clear your doubt. Thank you.